Alright, in this video I'm going to be explaining DHCP messages and overall how DHCP works. There's a lot that happens in DHCP. It's very quick transactions. I think it's one of those protocols that we take for granted, but there's a lot that goes into DHCP and a lot of, with big networks, routing and everything like that. So DHCP is one of those most common protocols used in TCP/IP, and what DHCP does, first of all, it stands for Dynamic Host Configuration Protocol, and you can dynamically get an IP address as you travel from different LANs. So of course different LANs have different subnets, have different requirements. So as you travel from one place like a coffee shop, and then you go home, and then you go back to the office and you're using Wi-Fi, you're not necessarily going to be using the same address every single time, and your default gateways could change as well. So every time you enable your NIC or your wireless NIC for DHCP, if DHCP works, then you will get an address. So in this topology and in today's video, I'm going to explain how everything works from the client going through a router to a DHCP server itself. And over here I have these 4 messages, and this is exactly what we're going to capture and dissect on what's happening. So the first thing that happens, the host, the DHCP client, laptop, whatever, is going to send out a discover message. It's a broadcast message, and it's going to source this message on port 68, and then he's going to send it to the server via port 67. So the server is listening on port 67. Okay, so he's going to broadcast that out, and what we know about broadcast messages is what? It stays within its layer 2 broadcast domain, or its layer 3 network right there. So this broadcast message, which is right there, only stays there, but how does that message get to R3? Well, this is where this command on the router's interface comes into play, IP helper address. What that command does is, if it receives a broadcast message on certain ports, it's not just DHCP, it's other ports like maybe TFTP, TACAX, Time Protocol, other types of protocols as well, but DHCP is one of them. If it hears a broadcast message on that interface right there, he's going to forward it as a unicast message to R3. Then when R3 gets this message, it's like, oh, that's a discover message. Let me send an offer. So the server will send an offer message right there, sent by the server, and he'll unicast it. Now, whether this client is on the same LAN or not, he's going to unicast that message straight to it. If it's on a different LAN, like how it is right now, he's going to unicast it to that interface, and that router and that router's interface, he's going to keeps, I don't want to say a table, but he keeps this discover message sort of in cache and remembers, okay, I received a discover message on that interface, and I know that MAC address too. And when I get this unicast message back from R3, I'm going to forward it to the MAC address of R1, because remember, R1, it has a MAC address that's statically set. That's a burnt-in address. That does not change. The only thing that does change is layers 3, and this is what DHCP is all about. So, offer message goes from R3 to R1. Let me clear this off. Goes back to R1, and it has a whole bunch of parameters in there. It's like a used car salesman and saying like, oh man, I got this good car for you. Look at all these great attributes. Do you want to take it? So R1 is going to look at this offer message, and and this could be several offers if there's multiple DHCP servers. Like if there's another one out here and it's a DHCP server, these 2 servers could be battling to say, hey, buy this car, take this address. So R1 is going to look at that offer, and then he's going to send a request. He's going to broadcast that out, but he's going to choose which one he wants. So let's say he chooses 3 at the moment, because that's the only one there. So he's going to send a request message. He still doesn't have an address. Okay, that's the most important thing. He still does not have an address, but he's going to request that that IP address that was in the offer message. So it's like you going back to the used car salesman and was like, all right, I'll take that car. It's good. And then once the DHCP server gets that request message, it's like, all right, let me get the paperwork. Bam. I'm going to send you an acknowledgement. You are good to go. You can now use that address. And that's pretty much it. It's like a four-way handshake type thing, and that's basically how DHCP works. But we're here to learn CCNA, so we need to know how to configure it and what goes wrong and all that stuff. So I'm going to probably do a couple captures on two different links so you get to see the messages that go from R1 to R2 and then from R2 to R3. All right. I have a basic config on R2 and R3. Like, I just have the IP addresses set. So we are going to configure this IP helper address and configure the DHCP pool. So let's start with R3. Let's actually configure the server itself. So let's see here. Let's shrink this down a little bit so I can keep this next to me. All right. So we go into global config, and well, let me double check to see if I actually configured fast Ethernet 1/0 show IP interface brief. And we did. We got it. I'm gonna do this a little bit. Okay, good. So first thing, let's create a DHCP pool. And when it where it says name right here, you could actually put whatever name you want. So in a real network, you'll probably name it something what this network is going to be about. So like, let's say this is the user pool where users are going to get their address. So you'll say IP DHCP pool, a question mark, and it says word. What's the pool's name? So it's for users, so we'll say users. Notice we are in a DHCP configure mode, and then this is where all the parameters come into play, all the great attributes for this pool. So what is the network? The network, well, I already have it set. The network is going to be 192.168.0.0/24, so that's what we're going to use. But in a real network, it's whatever you designed out. Okay? So, cool. Bam. Then, when this client gets an IP address, where is he going to send his traffic? This is where the default gateway comes into play. Now, on a Cisco router, we call it default router. And then that is going to be... ooh, that's wrong. That's actually not supposed to be it. That's not supposed to be it. It's supposed to be 192.168.0. Right. That's what it's supposed to be. This default router is supposed to be used for this guy, so where if he wants to get out of his network, he's going to send it to R2. So that's the default router. It's the default gateway that we all know if you ever looked at your IP settings before. So default router, 192.168.0.1. Bam. If you want to push out a DNS server so people could get out to the internet and they could resolve domain name service resolutions, go for it. 8.8.8.8. Anyone know what that is? It's Google. It's Google's DNS server. And then you could actually give a domain name. So I'm going to put CCNP Seth because that's me. Bam. All right. And I also have this command right here, IP DHCP exclude address. This is where if you want to reserve some addresses, like you should definitely reserve this 0.1 address because that's the default gateway. You don't want anyone getting that address, so you can reserve it. So you exit out of that DHCP config and say IP DHCP exclude address, and then what is the low IP address? 192.168.0.1. 2, what is the high? 192.168.0. Let's say 10. We want to reserve 10 IP addresses. Maybe there's like some static printers that we're going to add on this network or something. So go ahead and enter. Bam. And for basic DHCP configs, that's all we need to do. And if you want to have another DHCP pool, like let's say for VoIP users or for printers or for other types of users, special users, or for different VLANs, whatever, you could just go ahead and create the pool and follow these addresses, all right? One more step. Let's go into R2 and create this. Now, when you do this this command on the interface that is going to be receiving those broadcast messages, which is that right there. So, interface f0/0, IP helper address, and then this is where we are going to send those broadcast messages, and we're going to turn those broadcast messages into unicast messages. Bam! That is it. All right. Let me start up Wireshark right now. Let's go into R1. And let's go into f0/0. Hold on, do show run interface f0/0. Let me make sure that DHCP is set, but the address is, or the interface is shut down. So let's open it up and let's view those messages. There's the discover, there's the offer, request, and acknowledgement. Sweet. So that's what we're looking for. Now, one thing I want to point out here that's important is in this discover message, look at that. That is the source address. Why do you think it's 0.0.0.0? And why do you think the destination is 255.255.255? This is sent by the client. It's because it doesn't have an IP address yet, but yet it still needs to send traffic. So that's the layer 3 addresses that it uses in the discover message. Okay. Let's actually bring this up. And let's see what's here. So we have the boot flags, it's the broadcast flag, client IP address is 0, everything is 0 because this is the very first message and it doesn't know anything. Yeah, nothing too special. I mean, it gave its own host name in there saying, hey, I'm R1, that's cool. Okay. Now, let's go to the offer message. And where did this offer message come from? It came from the server. And here, let's see, offer, message type is a boot reply, and unicast message. So this is supposed to be a unicast message, but since I captured it from R2 to R1, R2 turned this unicast message back into a broadcast so he could send it to R1. But if I were to do a capture from R3 to R2, we would have seen this offer message go out as a unicast, which I'll have to do after this. So let me go back to this. So here, let's see. Here is the address that the server offered. Here is the relay agent address, 0.1, which is this guy right here. And let's see here, what else? The MAC address, client MAC address is there. That is always stored there. As you can see, 70000, that's right there. So every message that comes in, the server and the middleman knows who exactly asked it because the MAC address is in there. And then the other parameters, let's see, the domain name. Hey, I put that CCNP set, that's in there. The router, there's the default router. Subnet mask should be a /24, right? So all of these other parameters are in this offer. This is that used car salesman trying to sell you things. Then another broadcast message. Notice that it's still all zeros all the way to 255. And since this is sent by the client, look at that, source and destination port. UDP 68 to 67. 67 is the server, 68 is the client. And he still doesn't have, he still is not using his IP address that he's using, he's almost confirming it with this request message saying, hey, you know that offer you sent me? Yeah, I want it. And I want all this stuff. So all these things should be in here. He knows who the server is. He knows the IP address that he wants, but he doesn't have it yet. And all these extra other options that are there. Okay. Then the last one is the DHCP acknowledgement sent by the server. It was like, all right, buddy, you can take it. Here's your IP. Here's the basically everything that's in the offer message is repeated, but now it's in an acknowledgement, which means that the client can actually use it now. Right? Again, UDP 67 to 68 server to client. All right. So let's close that out and let's stop that. Let me do one more capture and let me get rid of this address. Let's do one more capture. I'm going to go a little bit quicker and see what this server is sending to the IP helper interface. Okay. So let's start capture. Let's do it on R2s. Yep, that'll work. And then let's do a no shut here. There's the discover, offer, request, and acknowledgement. Now here, all right, let me stop because that's all I need. Now notice here, everything is unicast messages. It's because this, in this topology, he is strictly talking to this interface right here. So these are always going to be unicast messages. And this is where R2 turned that broadcast message into unicast message. Okay? So, yep. So it looks like 192.168.0.1 is sending a discover message to the server of 10.10.10.3. It's like, wait a second, but you already have an address. Remember, like I said, he's just the middleman and he's turning it into a unicast message. All right? And then the offer. The offer is sent directly to that helper address, but that right there is what tells the helper, hey, it's actually destined to that client's MAC address, right? So that's very important. Relay agent, again, he's just a middleman. Okay? I think that's all I really wanted to do. I hope this gave you guys a better understanding of DHCP, how it works. It's a quick four-way handshake, and just know that it's between client and server, port 67 to 68 UDP. The client always sends out broadcast messages. The server always sends out unicast messages. Broadcast messages? Unicast messages. Yeah. Okay. And those are all the configs. Those are the basic configs, and this is how you set it up on a router. I hope this was informative for you, and I'd like to thank you for viewing.